Today we're talking about angles of elevation and depression, Unit 8, okay? Trigonometry. You guys are going to be able to solve and draw problems respectively using trigonometry, okay? More specifically, right triangle trigonometry, all right? We're going to start off by reviewing trig. This is from geometry, okay? Some of you guys took geometry last year in 9th grade. Some of you guys took it in 8th grade. So I don't know who taught you what and how much they taught you, okay? So I'm assuming that you know nothing or you remember nothing, okay? But that right there is in the blue. That hopefully should sound familiar. SOHCAHTOA, okay? SOHCAHTOA was the little thing that you were taught back in geometry of how to find side lengths and angle measures of right triangles, specifically right triangles, okay? Here's an example of a right triangle, okay? Each side has a respective name, okay? And it's based off of some type of given angle, okay? So let's say here you're given this angle here. And if you're curious, what's that little pink thing that I just wrote? It is called theta, okay? It is a Greek letter. It does represent an angle, okay? Based off of this angle, this side right over here has a particular name. Not adjacent, it's opposite. And the reason why it was called the opposite side, because it's opposite of the angle that you're given or the angle that you're trying to find. Or think of it like being across from the angle that you're given or the angle that you're trying to find. But the angle, but the side is adjacent, the one that's down here. What does adjacent mean? Next to. It is the side that's next to the angle. Not to be confused with the last side, the hypotenuse. And this will always be the hypotenuse because it's always across from the right angle. Always. So the hypotenuse is always easy to identify. You just got to find where the right angle is and draw a line across from it. Okay, the side across from it is the hypotenuse. Okay, that's where the O, the H, and the A in SOHCAHTOA represent either opposite, hypotenuse, or adjacent. So sine, not sin, sine, everyone say sine. So when you say sine theta equals whatever over whatever, you're not going to say sin, okay? Sine. Sine is O over H, or in other words, opposite over hypotenuse. And that's exactly how you would set up the equation to solve for either a side length or an angle measure. Okay? I'm going to take one quick pause before we do this example because for these types of problems, you are going to need your calculator, okay? So go ahead and get your calculator. Okay, so when you're looking for, in this particular case, we're looking for theta. Theta represents an angle, okay? The same way you attack this problem is how you attack any of the other problems. You have to determine what sides are you given or that you're looking for, okay? And it's always based off of the angle that you're given. Never the 90-degree angle. Never, never. 4.1, that is our what side? It's our opposite side because it's across from the angle that we're trying to find. The 7.7 is our, careful, it's our hypotenuse. Look at the triangle. The 90-degree angle is opposite of that side. And remember, the hypotenuse is always opposite of the 90-degree angle. So because we have O and H, we are going to use sine to solve this problem. Besides the fact it's in the sine section, I mean, that's how you would do it normally. So you set it up. Literally, just like the formula. Sine of your angle, which we don't know, so we leave it as theta, equals our opposite side, 4.1, over our hypotenuse, 7.7. This is important. So, it's important that you set up this equation because without it, you're not going to know exactly what to do. And on top of that, let's say you don't have a calculator at home or a calculator that can do sine. If you can at least set it up to the point where this is what I would type into my calculator. If I had one, I can still give you credit. But also, if you have an answer that is not right, I at least know where you made your mistake. Does that make sense? So set up this equation. Now, whenever you're looking for an angle, you always do the inverse of that respective trig function. So whenever you're looking for an angle, you always use the inverse of the function. What's the inverse, you say? Well, if you look on your calculator where the SIN button is, where the sign button is, right above it in green, is signed to the -1. That means inverse. Okay? So, how you would write it would be sine inverse of this fraction, 4.1 over 7.7. And that's what you would type into your calculator. Now, if you're using these TIs 30XAs, you type it in backwards. Okay? You do 4.1 divided by 7.7, enter. Then second sine. Divided by 7.7. And that should give you the answer. The second sine. Did you do second sine? What'd you get? 32.817. So three significant figures will put us at 32.817. Remember, three significant figures. You start with your first non-zero number and count. Okay? And then that will be your angle. So let's recap. You set up the trig. You figure out what the sides are. You determine what trig function you're going to use. And then you set up your equation. If you're looking for an angle, you do the what? The inverse of that respective trig function. If you notice, sine, cosine, and tangent all have them. Okay? And there you go. Questions on sine? Let's look at cosine. Okay? Again, if I go back and label these different sides, remember the side across from the angle that's given to you is your opposite. The side that's next to your angle. And the side that's across from your 90-degree angle is your hypotenuse. And in SOHCAHTOA, the CA stands for cosine equals adjacent over hypotenuse. So that means if you have your adjacent side and your hypotenuse, or you're looking for one of those, that means you're going to use the cosine function. Take a look here. You are given 25 degrees. You always use the angle that's given to you, never the 90-degree angle. That 8, what side is the 8? Is that my opposite, my adjacent, or my hypotenuse? It's my adjacent, because the x is because it's across from the right angle. Is everybody understanding how we are labeling this triangle? So that's why we're going to use cosine here, because we have adjacent and hypotenuse. Even though we're looking for our hypotenuse, we still are going to use cosine. So let's set this up. Cosine of our angle, which is 25 in this case. We're given 25, equals my adjacent side, which is 8, over my hypotenuse, which is x. Am I going to use the inverse here? No. I only use the inverse when I'm doing what? Looking for an angle. I'm not looking for an angle here. I have my angle. I'm looking for a side length. So now this just becomes algebra, like solving for your variable. How do you solve for x? I'm looking for a side length. So now this just becomes algebra, like solving for your variable. I feel like it's deja vu. I looked at y'all weird like that before with the whole divide 1 over 8 thing. I feel like we have. Can we, okay, Amy. I looked at y'all weird like that before with the whole divide 1 over 8 thing. No, don't divide 8. Well, you said divide 8 by that. Oh, I want to make sure that I'm understanding her correct. You're saying do cosine 25 divided by 8? Yes, that is the correct thing to do. You're going to take 8 and you're going to divide it by the cosine of 25. Now, I don't understand. I mean, I see why you guys do the 1/8 thing, but then I feel like adding like an extra step. But whatever. Multiply by x, and then divide. Yes, that's what I'm looking for. But I always get the 1/8 thing, or where you. I don't know. I don't know. It just it messes me up. That's what I'm looking for. But I always get it messes me up. It still works the way you're going to do it, but you're going to do an extra step, or actually having extra 2 steps when you actually go through the process. But this is exactly what x equals. So if you don't have a calculator, you can write 8 over the cosine of 25, and that's perfectly fine. But if you have a calculator, I expect you to actually do this. Now, the one sucky thing about these calculators is that you have to do 8 divided by 25 cosine enter. 8 divided by 25 cosine enter. What'd you get? 3 to 3 significant figures. Make sure you did 25 and not like 24, something like that. Okay? But again, you type in 8, the numerator, divided by the angle, trig function, enter. Okay? These are, all the angles are in degrees. Yes, yes. That's the easiest kind. You just type it straight, just like that. Just type it straight in, and you're good. You ain't got to do nothing fancy. Straight in. You'll be working with those in the future. I wish we could work with them now, because these, well, one, they're only $5. So, but I mean, you also need it for algebra 1 and geometry. So, all right. Is everyone good? Mm-hmm. I mean, you could technically get those now for algebra 2. You don't really need these because there's no EOC anymore. And plus, you'll use that more. It's expensive, but it's worth it. It's worth it. Especially if you're planning to go anywhere like math-based, like future, business, engineering, science. All right. Let's change up the angle for tangent. Let's change up the angle for tangent. If I made this theta, that angle at the top, theta, then what would this side be? This would be my adjacent side. The side over here would be my opposite. And of course, and this will always stay your hypotenuse because it's always across from the right angle. So be careful, because depending on where the angle is going to depend on how you label your side. Okay? Tangent, TOA, and SOHCAHTOA TOA represents what? Opposite over adjacent. And that's exactly how you'll set it up. Label your sides based off of the angle. 9 is my what? And 3 is my adjacent. So, of course, we're going to use tangent, opposite, and adjacent. So we'll set it up. Tangent theta equals what over what? 9 over 3. Now, if you want to just say that that's just 3, that's fine. There's nothing wrong with that because 9 over 3 is just 3. But to answer this problem, I'm looking for an angle, which means I need to do the inverse. And remember, you get the inverse by pressing the second button and then the respective tangent button. So, for these TI 30XAs, you work backwards. So if you want, you can just do 3 second tan, and you should get your answer. So if you want, you can just do 3 second tan. 71.6. Should be 71.6.
I could.
You gotta do 9 divided by 3.
Oh, I didn't do that.
Yeah. And then second tan. There you go. With this, you'll do. Okay, now for you. Oh, okay. Press mode. Oh yeah, you gotta be in degree. That's the one downside about these. And then click enter. Now when you go back to type that in, you'll get the right answer. There you go. So you want to make sure you're on degree mode. Anytime you take out the batteries or reset your calculator, it goes back to radian. So Questions? Are you good on yours? No, you're taking the tangent inverse of 3. So you do 9 divided by 3 and then second tangent. No multiplication needed. Okay? Tangent, cosine, sine, they cannot stand alone. Okay? So in other words, they need to have an angle that's attached to them. You just can't say tangent or divide by tangent because there's no such thing as doing that. That's why you do the inverse. What is? It is it's okay. Sine, cosine, and tangent, they are functions, just like what a quadratic function is, a radical function, a rational function, etc., etc. Except they have their distinct features, which we'll talk about towards the end of this unit. But they're basically a ratio comparing the. Let's see. An algebra 2 answer. Is a respective ratio comparing the sides of a right triangle. Later on, you're going to learn about the placement along the graph that these different angle measurements and things represent. So, but that's for the future. We won't go too deep because it's algebra 2. I'll let pre-cal, kind of blow your mind a little bit, and then I'm going to let IB just totally, take your brain out and leave it outside. All right? Go get a marker and a felt. We're going to practice this a little bit before we move on to angles of elevation and depression. All right? Go get a marker and a felt. We're going to practice this a little bit before we move on to angles of elevation.